Now in this video we're going to quickly look at how capacitors alternate current as they charge and discharge. So first we're going to just start with this old schematic here. I showed that when you close this switch we have a current path. So they used to think current flowed from positive towards negative in a cycle, and then so the capacitor would fill up with positive on one side and would be less positive on the other, would be negative. Now we know that actually it's electrons. The capacitor, the power supply is pulling electrons out of the capacitor if that switch is closed and then putting them on this side, so there's an imbalance. Now after we have that imbalance, those electrons want to go back to their original place. So if we close this switch and the load allows it, electrons will flow out where there's extra electrons and then start filling in the space where they got pulled out of before. So that's what the discharge is. So the charging, we yank electrons out, making that more positive, and insert them in there, making this side more negative. So they're going in one direction and then the other direction as far as the capacitor is concerned. As far as this resistor is concerned, it's only seeing current in one direction, and then that switch in load, it's only seeing current in one direction. Current's only flowing that way as far as the rest of the circuit's concerned, but the capacitor and anything in series along here, so these wires right there, they will have current changing direction. So now oftentimes when I demonstrate alternating current, I use the polarity indicator here, and I do that with circuits where it's changing slowly, because if it's alternating really quick, both LEDs look like they're really on, even though they're switching which one is on really fast, faster than you can see it. So we have here a couple of LEDs. They're protected by a resistor. So this is a 1 kilo ohm resistor. We're going to use this supply set to 5 volts with current limited to 30 milliamps or less. The output is actually on now. So it's pretty straightforward. We have the protective resistor up here, and then doesn't matter which LED, we just have to keep track of it. So the short lead, the cathode, is connected to the resistor. Long lead, the anode, is down one row for the red LED. The green LED is the opposite. The anode is connected to the resistor. The short lead, the cathode, is down one row. So these two components are connected directly together at the bottom there. I can touch either one of them with the power supply, and it will make a connection to the other as long as there's a solid connection with the board. There isn't outs. So we will show that right now. We saw that the long lead, the anode of the green LED, is up here. So if that side is more positive, the green LED will light up. So I can either touch the red LED or the green LED. Whereas if we flip it, put the positive down here, the anode of the red LED is down there, cathode's connected to the resistor, and so there you can see the red LED lights up. And green LEDs are just naturally brighter. There's actually more current flowing through the green LED than the red LED, but they're just naturally brighter. So there you can see I have the other situation there that we saw. If you change the side that the power supply is on, then the red LED will be on. If that side, the anode, is more positive and the green LED becomes reverse bias, it won't light up. So now we're going to add a capacitor into the equation. So this is a 1000 microfarad capacitor. We can go up to 35 volts. I'm going to make sure I discharge it, and I think you might have seen that little spark there. And I don't think you want to leave these discharged all the time. You want to kind of give them a charge once in a while. I think that helps the chemistry. So before we connect to the circuit though, not a bad idea to discharge it. So I'm going to put the negative side of the capacitor to the resistor. I shuffled the resistor over because we're going to add another couple components to this row. So that side is going towards the negative rail. I added a jumper there to those LEDs to go to the negative rail. I clip the alligator clips to these jumpers to power the supply. And again, we're using 5 volts. So what I was doing in recent videos was ultimately taking a fairly high resistance, and so we'll just grab a 1 kilo ohm resistor right there, and I'm going to put that to the positive rail and then connect it to the capacitor. And while we do that, we can watch the current flow right there. So the green LED is on. Current's flowing in one direction right there. And so we went from completely discharged. It's going to take a bit to catch up. So it's going to only really charge up to about 2 volts. So not much, because the LED is blocking 3. I wasn't thinking about that. So I'm going to go up in voltage. We have 1 kilo ohm resistor right there, limiting current, and another one there. So 10 volts works just fine. So I didn't think that out ahead of time. These green LEDs block a lot of voltage, which won't give us much voltage left to power the red LED. So right now, the capacitor is probably somewhere around about 7.5 volts or so. And those are topics for other videos. Now I'm going to grab a 100 ohm resistor, so a lower value resistor. And what that will do is, now that the capacitor is charged, it'll have an easier path to go to the negative rail than the current that's coming in through that one when we're looking at conventional current. So going to the negative rail, 100 ohm resistor, there you can see that the red LED lit up. And it's not as bright as the green one for a couple reasons. It's just naturally less bright, and also we didn't have as much voltage to work with. So this is what I was doing recently. I had a capacitor getting current from the positive rail right there, just like that. And there was a microphone. So sometimes the microphone had more resistance, and sometimes it had less. Like right now, when I connect to ground, it goes down. And so the current was flipping back and forth. So of course that was very rapidly, and there wasn't much power. It was very little current being involved. But there you can see we are alternating current as far as this side of the circuit is concerned, plus that wire of the capacitor. Anything in series with the capacitor, if it's charging and discharging, will have alternating current like that. So the resistors do not. We have positive working our way towards negative through that resistor, and then if I add this resistor, now it's a positive going through there and through there. So it's going in one direction there. This is a single supply, and so right now we got a steady 10 milliamps of current, because we have about 1,000 ohms of resistance right here. So the capacitor is filled up, and so the current's going there 1,100, and so about 10 milliamps. When you have 10 volts, if I yank this, now you can see there's a less current as the capacitor charges. But the current's always going in the same direction as far as the power supply is concerned, and these two resistors. But for these three components, we have current changing directions. And so I already explained why before. When it comes to capacitor, there's two separated plates, and so the power supply charges them. It makes an imbalance in the plates, so that's why that side has to be more negative, and that side more positive. If it's polarized, there's non-polarized capacitors, you don't have to worry about that. And then after you charge it, or even when you're still trying to charge it, if you get a path, there's negative rail, there's negative rail over there, then it has a low resistance path to discharge, in which current goes in the opposite direction. So hopefully that all made sense. It's a little bit too much to explain while looking at circuits that depend on that. So every once in a while I'll throw out one of these videos where I demonstrate this alternating current from a DC supply there. So now the red LED is just naturally less bright. That may be a little annoying, so I'll grab another green LED. I think that's in the right direction. Yeah. And so you can see now they're about the same brightness, even though they're going in opposite directions. So that's something you have to account for if you want to make a circuit that uses LEDs to show which direction the current's going. We could just use separate resistors for each of the LEDs we won't have the LEDs in parallel anymore. We'd wire it in a different way where they connect to the resistors at a different spot, but the resistors both go to the capacitor if we wanted to. That way we could use a lower value resistor for the red LED. It would be brighter, but more current would be flowing, so it would kind of throw the timing off. But that's all topics for different videos. Thanks for watching. Check out one of these other videos that I'm posting. Subscribe and click like, the bell, and whatnot. I will see you in the next video.